Alright, so now let's do sigma notation. Alright, we are still going to use the example that we were using before, which was that we have a series 3 plus 7 plus 11 plus 15 plus ... Right, so let's say we want to represent this series in sigma notation. Okay, so the first thing that we need to do is to find the general term of this series. So we already know that the general term is Tn equals to 4n minus 1. Please make sure that you understand how we find the general term of the series. So to write this in sigma notation, which is a shorthand notation for writing the series, the sum of the series, we first need to understand some terminology. So this symbol that I'm going to be writing is capital letter S in Greek, which is called sigma, which is sigma in English. So this is capital letter S in Greek. So that's the notation that we are going to be using. So now when we want to write this in sigma notation, first we have to put the starting here, so you have to put the starting variables. So I'm going to say we are starting at k equals to 1, and I'm going to tell you why I'm using k and not n. And here I write the general term of the series, which is going to be 4k minus 1, and again I'm going to explain why I'm using k, not n. And here I'm going to write n. So since this series is going up to n terms, I haven't specified how many terms am I summing to, so since I haven't specified, I'll just write n. So the reason why we are writing k instead of n, it is because since I'm going to be writing n, I'm going to confuse variables when I write n and n, so I have to change. So this doesn't matter. This is also equal to sum to n of 4p minus 1 starting at p equals 1. So this doesn't matter, but this still is the same as that. Okay, this is the same. Okay, so let's look at this one. So this is 20, and this is k equals to 1, and this is 4k minus 1. So let's say we want to evaluate this sigma notation, this sum. How can we evaluate this? We want to calculate the sum. We know in order to calculate the sum, we need three things. We need a, we need the difference, and we need n. Okay, this is what we need to get the sum of a series. Why? Because as you can see, the formula says Sn n over 2, 2a plus n minus 1 d. So as you can see, we have n, we have a, we have d. So those are the variables we have. So once we fill in those, we can just calculate our sum. Okay, so from this we can see that our a is 3, and we already know that the difference is 4 from the previous questions. So we can just say, okay, a is 3, d is 4. But I'm going to show you another way which is going to be easy to see these values. Now the first thing that we can use, if we are given this and you don't have the series, just substitute 1 to k. So substitute this 1 to k. So you're going to get 4 times 1 minus 1, which is going to give you 3. And how can you get the difference? The difference is just the number next to the variable, which is 4 in this case, 4, right? And then n, how do we get n? We say this number 20 minus 1, the number at the bottom, plus 1. So top minus bottom plus 1, that's how we find n. So it's going to be 20 minus 1 plus 1, which is going to give us 20. We don't just say it's 20 because some other instances we don't start at 1, so you're going to have problems when you say it's just 20, the number at the top. So these are the values that we need so that we can get our sum. Let's just plug those in and then get the sum, right? So n is 20. Let me plug in that and say 20 over 2. Then this is 2 times a, which is 3, and then plus n, which is 20, minus 1 times d, which is 4. Okay, and we have to plug in that on our calculator. Let's use a calculator. 820. Right, so that's how we calculate the sum. Okay, let's look at a different example. Again, we want to evaluate this. It's going to be 11, and this is going to m equals to 1, and this is going to be 3m plus 1. Again, you can see in this instance I'm using m, but this is still the general term of this series. Again, I need just three things: a, d, and n. Okay, so that I can plug in on my formula and see which answer do I get. All right. So what is a? A, you just take this and plug it in there. So you're going to get that a is 4. Right. So let me just use that color, 4. And for d, d is any number next to a variable. In that case, it is 3. And for n, we have to say the top minus the bottom plus 1. We are going to get 11. All right. So we are going to be taking these and plugging them on our formula. So we want to calculate S11, which is going to be equals to 11 over 2 times 4 plus n, which is 11, minus 1 times d, which is 3. Then we close. Okay, then let's use our calculator to punch in that. So that's 209. So we've just got that the sum to 11 terms is 209. As simply as that. Alright, so let's look at this example. 19 starting from 3, 1 minus 2p. Again, in order to evaluate this, we are going to need three things: a, d, and n. Okay, so try to get these and see if you get the answer: a, d, and n. So for a, you are going to take 3 and put it there, so that you are going to get -5. D is any number next to a variable, that is -2, and n is 19 minus 3 plus 1, which is going to give you 17. Top minus bottom plus 1. Plug in on our beautiful formula for calculating the sum of an arithmetic series, and then we are going to get our answer. So this is going to be S17, which is going to be 17 over 2 times -5 plus 11, 17 minus 1 times d, which is -2. So this is going to be -357. So that's how we calculate the sum of a series. First we have to get a, which is the first term of a sequence, d, which is the difference, and then n, the number of terms, by minusing the top from the bottom and adding 1.